The Spring Framework is an application framework and inversion of control container for the Java platform. Spring Framework to work properly needs Maven build automation tool for automated management of dependencies, consistent project configuration, build automation, and strong IDE integration. Spring projects often have numerous dependencies, and Maven ensures these are correctly handled, avoiding conflicts and ensuring compatibility. Let's dive deep under the hood to see how this dependency management looks like. Let's use our simple example of triangle application that basically calculating area and printing out triangle details. Triangle application class is our entry point, just like in Spring Framework that is usually annotated with @spring-boot application. This class creates application runner class. This is the place where magic is happening. Crucial point where all dependencies are linked with the application. Runner invokes internally main controller that implements run method. Controller statically imports terminal class for printing results to the console and triangle class that is coming from the separated module. That's the whole difficulty, how to have these classes available during runtime. So let's dive into each one of them and see how they work. Let's begin from the top of hierarchy, our entry point. To imitate Spring application class, we create application runner class that is just like Spring class, is taking main class by utilizing Reflection API as any argument and invokes run method with arguments. Reflections in Java is a powerful feature that allows the inspection and manipulation of classes, methods, fields, and other members of a class at runtime. By having an instance of class metadata, we can later use it to get correct application context path. Run method will invoke runnable controller internally. Application runner class creates custom class loader in a constructor. We will get to it shortly. Class loader load classes based on main class entry point metadata. Next, once we have loaded classes, we can find runnable controller of our app and assign it to private field. Inside run method, we create new instance of controller, once again thanks to Reflection API that gave us access to internal metadata of a class. Through new class instance, we can get access to run method and eventually invokes it dynamically with instance object and application arguments passed into it. Now let's talk about the core of this application, our custom class loader. This class loader overrides main application app class loader. By having it on this level, we can load classes to have them available for the classes lower in hierarchy. Class once loaded can be reloaded, so that's why it is so important to do this at this stage. Our custom class loader has a reference to loaded jar file and a list of all classes that were loaded. This method ensures that the JVM will not apply internal logs for class loading and instead relies on the class loader to manage synchronization, allowing for custom approaches to thread safety. In a load classes method, we use our main application reflection to get application context path, which is the output jar file. Based on this path, we can start stream of internal data in a search of classes to load. Load classes by name method will put all loaded classes to class list. Load data method takes stream of the whole application context jar file and search for any internal dependency jar file. Get entry data method reads loaded data stream and assign it to byte array accordingly to the size. If size of the file is not available, we will loop over data stream, put it into byte array output stream and transform output stream into array of binary data. By iterating over files, program checks for files with that class extension. In this case, file binary data will be assigned to the map of class name key. In case of encountering another nested jar file, we will recursively invoke this method once again with stream of this nested jar file. Now in our loading classes methods, first we will transform map keys into set. We are passing new array to this method just to set the output type of string. It will internally create new array anyway. Once we have array of class names, we can loop over and invoke parent app class loader method. When class was not found, we will invoke our custom find class method that will define class based on a loaded binary data. This is the place where all classes from dependency files are loaded to our application scope. By having this logic, we avoid class names conflicts as well. By loading classes in our custom class loader, now we can statically import them into our controller class. By having this class loader in our roots, we have access to these classes right now. Let's talk once again about our runnable controller interface. By implementing this interface, we can be sure that application runner will invoke run method of a correct class as a starting point of this application. As you can see, run method takes arguments as a parameter, so we can use them to calculate triangle area and print it to the console. That was a simple example how Maven is loading dynamically dependencies into our Spring project. As you could see, having access to classes through static import is not a trivial thing. So now we can appreciate more all these tools that are doing it automatically for us. See you in the next one. Dive deep into behind the scenes details of our daily use tools and frameworks.